Hello students. Today we have to get idea about very interesting topic from your paper, that is computational botany, and topic that unit we have to say that the probability and types of theoretical probability distribution. So actually, what is the probability that we should know? First of all, probability means something may can happen like that. It is the proportion of a times and events occurs in a set of trials. In a set of trials. So you'll have to, we know that. One example I will give you before starting this topic, then you will come to know that the exact probability. Tossing of coin is well known to you also, because before getting start the cricket match, the umpires, out of two umpires, one umpire toss the coin, and that tossing of coin, then there will be the head or tail of that coin that is not known to us. That is not known to us. We cannot say anything about that one. So one of the scientists, according to the Laplace, who is a French mathematician, I have to say that the probability is actually the ratio of number of cases to the number of cases to the total number of equally likely cases. So number of favorable cases, in the sense we know that at the time of tossing there may be the head or number may be tail. So that is the favorable case. Now total number of equally likely cases, head, and always you will have to keep in mind probability is a 1, isn't it? So tossing of a coin, suppose there is a head, 0.5%, 50% chances of getting the head and 50% chances of getting the tail. 50 plus 50, that is equal to 0.5, definitely 1, isn't it? So according to Laplace, French mathematician, probability is the ratio of number of cases to the total number of equally likely cases is there. Now, concepts of probability. First one, that is a random experiment. Experiments, or some terminologies are there in probability concept that we have to study. Random experiment, it is the one whose results depend on change that is the result cannot be predicted. That is the random experiment. Now what is the random experiment? We know that tossing of a coins is one of the experiment. Throwing of a dice is an experiment. Again, these are the examples of random experiments are there. Now in that one, what is trial? Performing a random experiment is called as a trial. Whenever umpire make the toss of coin, and whenever a tossing process is going on or performing is there, that is nothing but the random experiment. Now outcome, the result of random experiment after tossing the coin, head or tail may be there, that is nothing but the outcome, isn't it? When two coins, here example is there, when two coins are tossed, the possible outcomes may be both may be show the head. Out of that two, one may show the head or one may show the tail. Maybe first show the tail and second show the head. Maybe both can show the tails, isn't it? So outcomes are nothing. These are the outcomes of a result of a random experiment is known as an outcome, that you have to keep in mind. Now what is an event? An outcome or a combination of outcomes of an random experiment is called as an event. Example, tossing of a coin is a random experiment and getting a head or tail is an event, isn't it? Getting head or tail is an event that you have to keep in mind. Now, what is sample space? Each conceivable outcome of an experiment is called as a sample point. Isn't it? Each conceivable outcome of an experiment is called as a sample point. The totality of all points is called as a sample space. Totality of all points is called as a sample space and it is denoted by S. Example is equal to H, T, H and T are the examples. Head, tail, head and tail are the examples. Now, equally likely events. What is equally likely? Two or more events are said to be equally likely if each one of them has an equal chances of occurrence. Isn't it? Equal chances of occurrence, that are nothing but the equally likely events. Suppose coin is tossed, so there may be the head or maybe the tail. So both are having a equal chances of occurrence. Isn't it? Example, tossing of a coin is there. Isn't the event of getting a head, and the event of getting a tail are equally likely events. Equally likely events are there. So you'll have to keep in mind what is equally likely event. The each and every way how to say that either tail or head has equal chances of occurrence. So that is equally likely event. Either that may be the head event or maybe tail event. Any event we can get having a equal chances, 50% chances are there. Now what is mutually exclusive event? Two or more events are said to be mutually exclusive event. Occurrence of any one event excludes the other. Here you have to write said, S-A-I-D. So two or more events are said to be mutually exclusive events. Occurrence of any one event excludes the occurrence of the other event, that are mutually equally events. Isn't it? One thing is there, mutually exclusive event. That mutually exclusive event cannot occur simultaneously. Keep in mind. I will give you example. Suppose there is a birth given by one of the mother to the child, isn't it? And only single child has been born, we have to say that. Then we have to say that either that may be the male or female. Either that may be the male or female is there. Isn't it? Again, suppose we have tossed the coin. Isn't it? So there will be the head. So here head event has been, we have to say that, excluded to the tail event. So such a type of things are known as a mutually exclusive events. One can only occur at a time, and when one occurs, other never occurs. Such a type of things exclude, or we have to say that excludes, that is nothing but the mutually exclusive event. Now, exhaustive event. Events are said to be the exhaustive when their totality includes all the possible outcomes of random experiment. Example, while throwing a die, possible outcomes are 1, 2, 3, 4, 6, and hence the number of cases 6. Exhaustive events. There is no only single, isn't it? All possible outcomes are possible when we will throw a die. We may get the figure 1 or maybe 2, maybe 3, or all these are. Now complementary. What is complementary event? The event A occurs and event A does not occur are called as a complementary event to each other. Again example is there. Again example, throwing of a die the event getting odd number, that is 1 2 3 5, and getting of a even number 2 4 6. These two events are mutually exclusive and complement to the each other. Complement to the each other. When there would be the odd number, definitely there should not be the even number. Now, independent, that word itself tells independent. Events are said to be independent if the occurrence of one does not affect the other. In the experiment of a tossing of a pair coin, occurrence of the event head in the first toss independent of a occurrence of a event head in the second toss, third toss, and subsequent tosses. So example is that independent in the sense, suppose first of all we have taken the toss of coin and there is a head, and suppose we have taken the second toss. So we cannot say, isn't it? We cannot say there would be the head or maybe the tail. So that occurrence, that outcomes never depend upon the first result. So suppose first time we have tossed a head is there and second time there is a tail. So cannot we say that on third time there will be the head and alternate there could be the tail. So there is no such a type of a things are there. So outcome of first event never depend upon that, never we have to say that correlated with the second, isn't it? So that is nothing but the independent events. Now, theoretical frequency distribution is constructed on the basis of experiments. It can be calculated on the basis of theory probability. So it is called as a probability distribution. It is called as a probability distribution, and its definition, a listing of a probability for every possible value of a random variable, is called as a probability distribution. So this definition you have to always remember. Listing of the probability for every possible value of the random variable is called as a probability distribution. Probability or theoretical distributions are classified in three types. Binomial, first one. Second one is Poisson distribution. Third one is a normal distribution. That you have to keep in mind. Probability or theoretical distributions are classified into three types, that is a Poisson distribution, normal distribution, and binomial. Now, out of that three, we have to get idea about the binomial distribution. Bi, that word is bi means two, you have to keep in mind. Here, bi means two, binomial distribution. It was introduced by the scientist, Swiss mathematician, we have to say that James Bernoulli, in 1654 and 1705. So that is the period. In that period, he has discovered this binomial distribution or studied on that one lot and given to the world related with the probability distribution, that is binomial distribution. Binomial distribution is of two names are there. It deals with the possessing and non-possessing events. Definition: binomial distribution may be defined as the probability distribution expressing the probability of one set of dichotomous alternative, that is success and failure. Two are there, success or here the two independent constants n and p known as a parameters of the distribution. The distribution is completely determined if n and p are known. X refers to the number of success. So binomial distribution you have to remember, which is given by the scientist, that is, or mathematician, we can say that the Swiss James Bernoulli. Now, what are the conditions of the binomial distribution that we have to study? Some conditions are there of that binomial distribution that may can ask in the examination. You will have to keep in mind the number of trial is a finite, isn't it? The trials are independent of each other. The probability of success P is a constant for each trial. For each trial. Each trial must result in success or failure. The problems relating to the tossing of a coin or throwing of a dice or die or drawing of a cards from a pack of a cards with a replacement lead to the binomial probability. So these are the examples of the, we have to say that the, and what is the exact, so the number of trials is a always finite, that is not a infinite, means specific number should be there for binomial distribution. The binomial distribution which is given by, we have to say that the scientist. Now binomial distribution having some conditions, and it works with the help of these conditions, and these conditions only should be fulfilled by that event. So finite means definite, we have to say that, and that number we have to write n is there for that finite. Now what are the characteristics that also known to us about the binomial distribution? Binomial distribution is a discrete distribution in which the random variable assumes the values 1, 2, 3, 4 up to n, where the n is the finite number, isn't it? Mean of binomial distribution always n and p, isn't it? N and p is there. P stands for the success. Variance, that is equal to npq, that is success failure multiplied by n, isn't it? Multiplied by n is there. Standard deviation, for your kind information, standard deviation formula is sigma is equal to under root of n, p and q. Standard deviation sigma is equal to under root of a npq is there, isn't it? npq is there. In case of coefficient of skewness, that is equal to, coefficient of skewness is equal to q minus p divided by under root of npq, isn't it? Coefficient of skewness, that is equal to q minus p divided by under root of a n, under root npq is there. Now coefficient of kurtosis, k I will write here, is equal to 1 minus 6 of pq divided by npq, isn't it? So these are the formula that you have to remember in case of the characteristic of binomial distribution. Mean is always equal to np, variance is equal to npq, standard deviation is equal to under root of npq, coefficient of skewness is equal to q minus p divided by under root of npq, and coefficient of kurtosis k is equal to 1 minus 6 pq divided by npq. Then these formulas are you have to remember, and these are the characteristics we have to say that of a binomial distribution. Am I right? The mode of binomial distribution is that the value of variable which occurs with the largest probability, it may be have either one or two mode is there. That is also one of the 7th characteristic of binomial distribution. If two independent random variable x and y follow the binomial distribution with parameters n1 comma p and n2 p comma p respectively, then their sum x plus y also follow the binomial distribution, that is n1 plus n2 comma p, isn't it? So that you have to keep in mind what the things are going to happen in case of this one. So these things should be always in the bracket, isn't it? n1 plus n2 n1 plus n2 comma p in bracket. So these are the, we have to say that little bit characteristics of the binomial distribution that you have to remember when that. But so definitely first one, that is a binomial distribution is a discrete distribution. Again, mean is equal to np, variance is equal to npq, standard deviation is equal to sigma is equal to under root of npq, coefficient of skewness is equal to q minus p divided by npq, coefficient of kurtosis is equal to k is equal to 1 minus 6 pq divided by under root of a divided by only npq, not under root. Now Poisson distribution, 3 distributions are there, isn't it? Binomial distribution, Poisson distribution, and normal distribution. Now we have to get idea about a Poisson distribution, isn't it? So Poisson distribution, it was discovered by French mathematician cum physicist Simon Denis Poisson. Simon Denis Poisson. Simon Denis Poisson in 1837. It is also discrete distribution, as we have seen in case of binomial distribution is a discrete distribution. Similar way, this Poisson distribution is also a discrete distribution. It is derived it as a limiting cases of a binomial distribution. For n trials, the binomial distribution is a q plus p raised to n, isn't it? Probability of x-axis is given by p is equal to in bracket x is equal to n cpx into qn minus x is there. So this formula. If the number of trials n is a very large and the probability of success is very small, so that the product is np is equal to m, is a non-negative and finite. What is the definition of this Poisson distribution? If the event is a very unusual in a great number of trials over a long periods, the following distribution is called as a equation. Following is called as a distribution formula for the probability of x success is given by. What is the formula for that one? Isn't it? Regarding Poisson distribution, P is equal to, P in bracket x is equal to small x, that is equal to e raised to minus m raised to x divided by x, isn't it? Here x is equal to small x is equal to 0, 1, 2, etc. Isn't it? So you have to keep in mind the m is always greater than 0. Mean value, here m is known as a parameter of the distribution, so that m is always greater than 0. Since the number of trials is a very large, probability of p is a very small, and it is clear that the event is a rare event. Students, one example I will tell to you about this one Poisson distribution, that is nothing but the persons killed by the kick of horse. Very simple. This never happens actually. Many kicks are, we have to say that, given by the horse to the human being, but we cannot find that death which is caused because of a kick of a horse. This example you have to keep in mind, so you might have understood all these things, isn't it? Another examples are also given here. Number of blinds born in a town in a particular year. Rare event is there. No, birth taking place in each and every town, particularly in the year. So more than 10,000, 5,000, isn't it? But blind, most of times no, there is blind borns or take birth in throughout that year. So rarely happen. Number of mistake committed in a type pages. very small in number of students scoring very high marks in all subjects. For example, suppose we are having a 5 subjects, and there are the 50 students. Each and every student have scored the marks above 90 degrees centigrade, above 90 percent in each and every subject. It is not possible. It is not possible. It happens, we have to say that, once in a 100 years. Is it so rare event is that one? The number of plane accidents in a particular week, so never happens. Actually, it may happens within a year, or within a 2 year, or by within a decade, like that. So every week there is a no, we can find the accident of a plane is there. Number of suicide reported in a particular day, we have to say that. That is also the best example of a Poisson distribution. Now, as we have seen the conditions required for, we have to say that, the binomial distribution, similar way we have to find out for the Poisson distribution. The number of trial n is indefinitely large. In case of, we have seen binomial distribution, that is a finite. Here we can find infinite. The probability of success p for each trial is a very small. In case of binomial distribution, probability of success is a very high, isn't it? Again, np is equal to m. M says is a finite. M is always greater than 0. So these are the conditions of Poisson distribution that you have to compare with the binomial distribution. So you may come to know that. Now, here some characteristics of Poisson distributions are given. Already we have said the Poisson distribution is also a discrete distribution. Again, the value of P means success, Q means failure, is applied in a situation where the probability of success P of an event is a very small, and that of failure Q is very high. So you have to compare these characteristics. Always here, probability of failure is very, very less, and probability of success is very high, isn't it? Probability of success P is of an event is very small. Keep in mind, birth of a blind in a city per year, very success, we have to say that is a very, very rare, and failure always there. The parameter of the Poisson distribution is a m. If the value of the m is known, all the probability of Poisson distribution can be ascertained. Values of constant mean is equal to m, that is equal to variance. M is equal to variance, so that standard deviation is equal to under root of m. Poisson distribution may have either one or two modes. Additive property: if x and y are two independent Poisson distribution with parameters m1 and m2 respectively, then x plus y also follows the Poisson distribution with parameter m1 plus m2. As an approximate to the binomial distribution, Poisson distribution can be taken as a limiting form of a binomial distribution when n is large and p is very small. N is number of trials, p is number of success is very small, such a way that product, that is np, is equal to m, remains constant. With this, thank you very much, students. This topic is very, very, we have to say that, interesting. You will have to understand first of all the meaning of each and every terminology, and then you will come to know that or understand very well. So now from this one, normal distribution, that you have to study on your own, because already I have taught you the two distributions, that is the theoretical distribution, that is a binomial distribution and Poisson distribution.